Hello there, I hope you're doing well wherever you're watching me from. So we've done a number of experiments with electricity, but there are some requests that I saw in the chats or in the comment section of our YouTube channel about doing some questions on electricity, specifically when the resistance of a given wire is changing. So I have a sample paper here that we're going to use, and I'm using, so this is Physics 0625, that is IGCSE. I'm going to use this paper of May-June 2022, variant 1, that is paper 5-1. So as I always mention, if you've watched some of my videos about particle, please, the very first thing that you do not look at the diagram and then you start doing the connection. Or the good thing with IGCSE, you will find the diagram is really connected, but then now you will take your time to understand the kind of connection that is there. Because sometimes a question can ask you, maybe change this kind of component into parallel, change this kind of component in series. So it is always good to be able to understand the connection of the circuit that has been connected in front of you, and please also confirm if that connection is in line with the diagram that you've been given. Someone may make a mistake during connection because maybe probably assuming that you have over 30 students or 40 students you are doing connection for, a mistake can be there. So please, the moment you find you are seated for an exam, the first thing that you're going to do is to read through the question to understand the aim of the experiment, what the question wants. And so in this experiment, you will investigate the resistance of a wire, carry out the instructions referring to the figure 3.1 as you can able to see on the screen. So in this diagram here, there's a resistance wire, and then there's point B, there's point C, those are like the ends. Then there's a voltmeter, an ammeter is there, a switch is there, then there's a power supply. So the first instruction you are being asked is to close the switch and measure the current I in the circuit. Okay? So that is without the sliding contact. Okay? So just connect B to C, and that is only. So without connecting the voltmeter. Okay, so you just connect that as shown, and then you get the reading of current. Place the sliding contact at distance L is equal to 5 cm from B. Measure and record in table 3.1 the potential difference V across the length L of the resistance wire BC. Open the switch, calculate and record in table 3.1 the resistance R of 5.0 cm of the resistance wire using the equation R is equal to V over I. Close the switch, repeat the procedure in B using L for different lengths, that is 25, 45, 65, 85, as you can able to see on the table. Open the switch. Then part C, plot a graph of R on the y-axis against L on the x-axis. Start both axes at the origin, 0, 0, you're able to understand why that is needed. Part D, use your graph to determine the resistance when R is at 50 cm of the resistance wire. Show clearly on the graph how you obtain the necessary information. So this is the last question. So it is always good to go through the question the way I've done, so that you just don't take data for part A, and then probably after dismantling your stuff, then you realize, oh, you were supposed to be able to take some data from, let's say, the last question, even after the graph. So without wasting time, let us start. So in this experiment here, I have not connected. I'm going to connect it with you, though in the exam you will be able to find it already connected. So this is the sliding, this is the resistance wire. It is here. I don't know whether you can see it, but you can hear that sound here. This is the resistance wire along the meter rule. This is a jockey. A jockey is for the sliding contact. That will be the sliding contact S. And then we have our wires here. we have an ammeter, digital ammeter, and we have digital voltmeter. Now, I've just realized that my cells are dead, so they have been drained. So I'm going to use this as my power supply, the DC part, of course, and I'm going to set it at 3. So this is set at 3, so that that is 3 voltage DC. And then we are going to, so it's already on. I'll just do that when needed. So let us start connecting as we can able to see or referring from the diagram. So the first thing first, uh, without the contact wires, so we need to arrange the main components the way they are. So the first thing, we have the resistance wire here. So this is the resistance wire. The voltmeter should be somewhere here. The ammeter should be somewhere here. You know, you need to arrange them the way they're supposed to be, the way they're appearing on the diagram to make your work easier. The power supply is here. I could have used this in the normal setup. You will not be able to use this. Not all schools can able to afford this for all students. So we will be able to use this in the exam for the power supply. But for today, as I've explained. All right, so there is something missing here. There is a switch that is missing. And the switch is here. So if I look at the switch is here and it's open. So the switch is here and it's open. So everything is now set. Our work is now to start doing the connection. So now we can able to confirm we have already set up the connection just the way we have been instructed. So all is there. This is a sliding contact, the jockey I was talking about, and that. So our contact B, this is our contact B, this is our contact C, just as you can able to see or refer from the diagram. So as you can able to see, the switch is open, and so let's take the first, so let's close the switch, be on. You are seeing that negative, the negative just shows that the battery, the battery of the ammeter is going low, so nothing to do. So I will close that. So we switch on, and then let us switch on this, and the reading that is giving us 0.223. 0.23. So every time you take the reading, you switch off. So that is 0.23. Then we record that. So power is off. We need to record our reading. So that was 0.23. Never forget to write the reading. So that is in ammeter. So that is amps. Sorry, not ammeter, but amps or amperes. So we are going to follow the instructions just the way we have been told. So our sliding contact is going to start at 5 centimeter as we take the reading. So this is the voltmeter reading, and I think you can able to see that clearly. So we're starting at 5. So at 5. Oh, sorry, this was off. Okay, so at 5. At 5, I'm getting 0.26, 0.25. Now, sometimes what you will realize, there's something that you've just seen there. When I put the value here, you see a negative. A negative just means that we connected the voltmeter wrongly. So if you see the negative, what you do, if that can be annoying, because some students may think that they want to record a negative value, just change the terminal of this. If you realize that your value, sometimes you may think that you connect it correctly, but then you see a negative. When you see a negative on the value, just change the terminal of that. The way I'm doing, just in the terminal. So just in the terminal from here to here. So if that is the case, then when I put it on, then now you can able to see clearly there is no negative. So that is just because of the terminal. So when you see the negative, please don't record that negative there at negative 0.25 apana. The answer here is 0.25. If you want to ignore the negative, no problem. But if it is annoying to you, just change the terminal the way I've done. So our first reading is 0.25. The diameter is still 0.23. So 0.25. Diameter reading is not changing anywhere. The current is the same, so the current that is flowing through B to C through this component is the same throughout. What was changing was the potential difference, and as you can able to see our data, the potential difference is increasing. And why is that so? When you look at this diagram here, so at first, let's say 0.5 centimeter was somewhere here. So voltage from here, PD, is actually directly proportional to the resistance. What does it mean? When the resistance increases, it means more work needs to be done. That is why potential difference has to increase. So when the length increases, we expect potential difference across the same length should also increase, because resistance is increasing. When resistance is increasing, that means more work is being done. So let's analyze here. We need to use this formula here to find R. Our current is 0.23. So we will have 0.25 divided by 0.23. That will give us 0.25 divided by 0.23. That gives us 1.08. 1.08. So into two significant figures, I'll leave it as 1.1. Then we have so using the data, we need to plot a graph of R on the y-axis against L on the x-axis. So we set our values from 0, 0, as we can able to see. So we need to understand the scaling that is being used. So the very first thing we need to do is to label our axis. There's always a mark for that. So against L in the x-axis, that means this side is supposed to be in centimeter, and then this is R in ohms. So that is already done. So that is already one mark by just labeling. So another thing we need to do is to understand the scale. So the lowest value for R is 1.1, the highest value is 11.1. So that is a difference of 10. But if you start from 0, so let's see, this is how many boxes there is: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you start here from 1, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be less than 11. So we may want to use here for 2. So this is 2, 12. Then for the L, the lowest value is 5, the highest is 85. That means, so if we use here, if we use 10, so this is 10, 20, 30, 40, 50, 60, 70, 80. I think that will be better. So this is 10. That is 90. So at least we are sure this will cover about 3/4 of the page. All right. Now, okay, let's just continue. There's a point that I want to mention, but we need it later on. So our work is now to plot the points. So we need to understand, for us to be able to plot these points effectively, we need to understand what each small box represents. So here there are 5 small boxes. There are 5 small boxes. So 5 small boxes represent 10. What about 1? That will be 10 over 5, so that will be 2. So it means that each small box here represents 2 centimeter. Okay, that's very, very clear. So this side, each small box represents 2 centimeter. Then this side, we have 5. So 5 represents 2. What about 1? So that will be 2 over 5. 2 over 5 is 0.4. That means along the y-axis, each small box is 0.4. So once we have that understanding, it becomes easier to plot our graph. So the first point is 5 and 1.1. 5 and 1.1. So 5 will be here. 1.1, so it is 0.4. 0.4. So I'm taking it slowly so that the next one I will just be moving very fast. So this is 0.4. 0.4, 0.8, 1.2. So this is 1.2, meaning 1.1 will be here at the center. So I'll do that. And I will repeat the same for all of them without talking. Now, before we draw the graph, but you can able to see here clearly, my data seems to be a straight line, and that is actually good. But then now, when you're doing experiment, you may not able to expect something like this. You may expect maybe, mine seems to be perfect. Thank God for that. But then now, for your values, they may not be this perfect. You may find some points being somewhere, something like this. So we may have points, your points can be something like this, maybe scattered, and then you're wondering whether you're supposed to draw a curve or a straight line. So when you look at something like this, always check the next question. The next question we have been asked here is to use your graph to determine the resistance R, this of the wire. Show clearly on the graph how you obtained your information. So being that we've been asked to draw this from 0, 0, it gives you another a hint. It means maybe probably our line should cut the y-axis, something like that. Or so it can be a curve or it can be a straight line. But then depending on your data, my data seems to be a straight line. Which I can able to draw the majority of points. So I need to balance to draw. So that is my point. Now I need to use the graph to answer the question. Use your graph to determine the resistance at 50 centimeters. So at 50 centimeter, I will come here at 50 centimeter, I draw that line. Then from that line, I draw here this is how we use our graph clearly. So I need to take the reading here. And this is a 6.04. And then because these are the center, that will be 2. So 6.6. That will be 6.6. 6.6 ohms. So this is 6.6 ohm. So, ladies and gentlemen, that is, boys and girls, that is how we do analysis, and that is how we are supposed to work out the questions.